All right, so we've just reviewed transcription, right? And how to figure out what your mRNA copy of a gene looks like. This is showing you how to then take that mRNA copy and then translate it into a specific amino acid sequence. So if we all recall, the goal of translation is to turn that mRNA copy into amino acids. And those amino acids are bound together into what is known as a polypeptide, and then polypeptides comprise proteins. And so at the end of transcription, you're left with an RNA sequence. Now, if you recall, remember we have to write this in a 5' to 3' direction, so you might get something that kind of looks like this. Now, if you recall, there's no T's, right? No T's are in the sequence, and that is because, right, this is RNA, and RNA does not have any T's. So first things first, when you look at your RNA sequence here, and you're getting ready to translate it into an amino acid sequence, the first thing that I want you to do is I want you to underline your start and your stop codons. So if you recall from the lecture on translation, we talked about our start codon being an AUG. All right, so it has 3 bases, an A, so for adenine, uracil, and guanine. This section tells that ribosome to start translating things into amino acids here. Then we're also looking for a stop codon. So again, remember a codon has to have 3 amino acids in it. And remember, once it says start here, okay, so that's one codon. This would be another codon, right? And then we're looking for a third codon that's going to tell it to stop. So this is how you would kind of take a look at this sequence. All right, so the question to ask yourself, do any of these act as a stop codon? And so for that, you're going to need to go to your translation chart, which is also posted in the folder for this module. So now we're going to go to our translation chart, and then I'm going to show you. So you have 3 different options. You can ignore this other side here, but you have 3 different options for stop codons. You have UAA, UAG, and UGA. So then you're going to look and see, okay, do any of the ones that I have kind of match what I see in our previous example? So we're going to go back to our whiteboard here. And it looks like we have a UAA, right? And that is one of our stop codons. So if we come back here, we go back over here, I'll show you. So UAA is going to be one of our stop codons. All right, so I'm going to underline that one as well. All right, so that means that when we are translating the sequence, we are going to start here, and then we're going to end here. So you can ignore this side, and you can ignore anything that comes after UAA. All right, so now, if you recall from our lecture, I talked about AUG being the start codon, and it has a little methionine attached to it. That is what that start codon translates to for an amino acid. It translates to a methionine. You could also double check this by going to look at your translation chart, and you'll notice that AUG is equal to MET, or M. So that's going to be your start. Does that make sense? Take a moment to take a look at your chart and to look at the example. Hopefully you are writing down this example and you're doing it with me. If not, I would suggest doing that. Okay, so now we're back to our whiteboard. All right, so I already told you that AUG is a methionine, so we're just going to go ahead and write that down here. Okay, so MET. So that is our first amino acid that we've translated from our mRNA sequence. All right, now we're looking at UAA. So, or UUA, sorry, not UAA. UUA is our next codon. So you're going to go back to your chart. So we're going to go back to our translation chart. We're going to take a look at it. So our first mRNA base, which is the 5' end of the codon, so that's a U. This is another reason that this always needs to be 5' to 3'. So U is our first one. Our second mRNA base is a U, and then our third is an A. So you're going to come all the way over here. You're going to go across here. We're in this little box up here because our first and second mRNA base were both U's. So it looks like UUA is a leucine, LEU. All right, so that means when we go back to our whiteboard, that means that your next one after this is Lu, or for leucine. All right, and you're just going to line them up next to each other, just like this. So I've done these little dashes to show you that yes, okay, things are they're connected side by side. All right, then our next one, we're going to do this. It goes CGA. So you're going to go find that on your chart. So we'll go back to our translation chart. All right, and then you are going to look for it. So we're looking for, I believe, CGA. So again, your first codon, and then you look for your second codon, and then you just drag it across for your third, and it looks like we have an arginine. So we're going to go back to our whiteboard, and this is now an arginine, which is spelled A-R-G, and you can put your little dash. All right, and then of course our last one, which we've already determined, is a stop codon. So again, we're going to go back to our translation chart. So our stop codon is UAA, which we already found on this chart before. And because it's a stop codon, it actually does not code for an amino acid. So you'll notice here it says UAA, it just means stop. All right, so in that case, going back to our whiteboard, this here is our amino acid sequence. All right, so it has 3 amino acids. Remember, this does not code for a specific amino acid. You have methionine, leucine, and arginine. You don't necessarily need to know the names of these other than how to line them up. So this would be your answer for this particular problem. So just double check one, that your mRNA strand is running 5' to 3'. And then second step would be underline your start and stop codons. So right here, underline AUG, underline UAA, right? Make sure you divide the rest of them into sets of 3, right? Because remember, a codon has 3 bases. And then you can go to your chart and look up the specific amino acid associated with those bases. And that's pretty much how you read a translation chart or a codon chart. It has 2 different names. I would also encourage you to watch the video by Amoeba Sisters that shows you also how to read a codon chart. Other than that, that is it. And please go on to the next video